Assalamualaikum and greeting to all. So this is the explanation for experiment 2. The objective for experiment 2, the first one is to practice plotting a best fit line graph, and second to interpret and analyze into graphical form. So untuk for experiment 2, you have to master two type of graph. The first one is cache graph, and the second one is plot graph, plotting a graph. Cache graph is easier because you don't have to detail in the graph, but plotting graph you need to put it very detailed, the symbol, the plot, and everything. Okay, we will look both here based on the exercise given, based on the report you need to submit. You need to submit the report starting page 206, 204 up until 206. 20, 20, apa ni? 203 up until 206. Do not use another paper except if it is not enough, right? And you will need a graph paper. What happened here? The first one, question one. In question one, it is asked you what graph is to be plotted, and then you need to sketch your graph. What happened here? Any equation in our syllabus can be turned in the form of y equal to mx plus c, right? What is this graph? Did you remember what y is equal to mx plus c graph represent? It is represent a straight line graph. Okay, you will have y-axis here, x-axis here, and since it is have c, you will have y-intercept. So this is your graph as y graph. C. So you will have this one, and you will have gradient here. Okay. So all the equation here, we want to convert it into y equal to mx plus c form, and you need to know what is to plot, x-axis, y-axis, and what is its gradient, and also what is y-intercept. Okay. For example, if you have uh, if you have if you have y equal to v equal to u plus ab. What is this equation? It is equation of velocity, acceleration, and time. Okay. If we convert it to y equal to mx plus c, we just need to rearrange it, which is we have v equal to at plus u. Now your v is y-axis, your a is the gradient, your t is x-axis, and your y-intercept is u. What you have to do when you plot a graph, we will always plotting a graph of um, dependent value. This is we call as dependent value, and this one we will call it as manipulated value. Okay, this all information have in your lab manual. You need to read it. So what you need to do is the first one, you need to name the graph. Ni kita nak sketch ni. This time we want to sketch the graph. Okay. What you need to do is put the name. We will have graph of dependent value v against manipulated value. Right? The next one, you must have the x-axis and y-axis. So your y is v, your x is t. Next, you must have the unit for the axis. Okay. Here your v unit for v is meter per second or meter second minus 1. and your unit for time is second. Then you will have a y-intercept, which is here is u, and you will have the gradient. Okay, next you draw a straight line, and then you will have your gradient. You need to write down the triangle. You need to draw the triangle and put it as your m. What is your m? M is equal to a. This is how you want to sketch a graph. This is everything that you need to have when you uh, sketch a graph. You need to have title. Sorry, the title must be lined up. Means that you must put a line under the title. It have uh, x-axis and y-axis, including the unit, and label for y-intercept if any. And then you will have the straight line and also the gradient. Then you will get the full mark. If one of them is not there, you will not have the full mark. Alright, let's look at the example of this one. Okay, you have P equal to 2 pi square root L over G. So here, this one is easy. P is your dependent and L is your dependent manipulated. Okay, it is easy. But for other equation, you need to refer to this table. Okay, you can see this table. Here, your P is x-axis, your Q is your y-axis. What happened here? You need to rearrange the equation into y equal to mx plus c, right? But when you put it, you want to put it as axis and y and x. This y and x, for here p and l, you can rearrange them so that it has square, square root, or cube, but it cannot have another. Ni dalam table ni, inside this table, this one x axis or y axis, you can have t square. This one you can have l square root l or anything else, but it cannot have another symbol. For example, you cannot have l over g. Ni tak boleh. This is cannot. Basically this one ramai yang buat for x axis, it will do r over r naught. No, cannot. For x axis and y axis, your symbol is stand alone, but it can have square, it can have square, square root, it can have square root, or it can multiply by the constant like 2 pi, but it cannot have another symbol, right? Okay, let's look at this one. This one, t equal to 2 pi square root L over G. We want to convert it as y equal to mx plus c. So, if you look at the table above, here, your x-axis is L, this is your manipulated quantity, your dependent value is t. So, your t should be y, your L should be g. We rearrange this equation, you will have something like this. 2 pi over square root g. Here is square root L. So now your y is t, your gradient is 2 pi over g, and your x is square root L. This is I said it can have square root, it can have square, but it must stand alone. Okay, so you put in the table here. So transform equation, write down again your equation, which is 2 pi over square root g and square root L here. Okay, then your x-axis is square root L, your y-axis is t, and only gradient can have combination of symbol. Only gradient can have combination of symbol. X and axis must stand alone. So this here y-intercept, kalau tengok kat sini, if you can look at here, there is no y-intercept. Your y-intercept is c. This is how you put it in the table. Okay, but at the same time, this equation you can transform it by square root both sides. can have you can have something like that. So you will have t square equal to 4 pi over g times L. 4 pi square over g times L. So here your y become t square, your m become 4 pi square over g, and your L become x. It can depend on your understanding on how to transform your equation. So this one, kalau if you use the second part, you will have t square equal to 4 pi square over g times L. X-axis UL, your y-axis is t square, your gradient should be 4 pi square over g, your y-intercept is still 0. Okay, alright. Now we want to sketch the graph. Okay, we want to sketch the graph. What you need to do is, the first thing, I will give you the two graph lah, to represent each one. So, the first thing you need to have is the name. Graph t against square root L. So your x-axis, y-axis is depend on that. So your y-axis is t, x-axis is square root L. Unit 40 is second, which is this is equation for a period, which is time taken for one oscillation. You will learn this in chapter 9. Its unit is second. Right? And L is for length and unit is for meter. Since you square root the symbol, you need to square root the unit too. Alright? Okay. This one, it doesn't have y-intercept, so the 0 is at the bottom. Something like that. Okay. And you will have to draw the triangle, showing that this is your M. Show your M. Your M is 2 pi over square root g. Okay. If you use the second equation, we will have graph t square against L. Line it up, and same you will have y-axis and x-axis. Now your y-axis is t square, your unit should be second square, right? And your L is L lah, and you will have your unit M. Same, you have the same graph, intersect at 0, you will have your gradient, your M is equal to 2 pi over, your gradient should be now 4 pi square over g. Either one is correct. So for another question, please use correct. You can have y-axis, you can have 1 over p ataupun 1 over, depend on what is the manipulated value. You can 1 over, you can have here, you will have ln ataupun log, right? And here you will have y-axis as 1 over r square. It depends on the equation. Okay, I will tell you the unit. This one is the equation for the length. F, P, and Q will have unit meter. This is the equation for voltage, capacitor. So unit for V, V naught is volt. If you have non-volt, the unit still volt. Unit still volt, V-O-L-T. But we will use V only for the symbol. And R is the resistance. The unit is ohm. This is temperature. The unit is Kelvin. Okay. This is force. Unit is Newton. And R, the unit is meter. It is a distance. So the unit is meter. Okay. Alright. So you need use the space given to answer the graph. The question. Sketch your graph here. You use all this. You will have 1, 2, 3, 4, 5 graphs. One already given the answer. And you have already another 4. Okay, now we will continue to the equation number 2. Here, equation. What you need to do is say you need to plan and tabulate in a new related data. And second, you need to plot a suitable graph. Third, you need to put is you need to find the value of EM. And then the third one is you need to find all of these must be in SI unit. Okay, now we have this equation. Let's say we have this equation. Okay, okay, we have this equation and we have this table. We have this table. Alright, first of all, we want to plot a graph in the graph paper. This one you need to plot one by one. This number is have correction. It is 0.16. Okay, what you need first, you want to plot a straight line graph, convert it as y equal to mx plus c. Okay, usually the upper one is manipulated value, the lower one is dependent value. So this should be your x-axis, this one should be your y-axis. Alright, so what happened here is you will have this equation. Y square equal to E over M mu naught square x to the power of 4 8v pi square t square I square. So you will have this as your y, this as your gradient. I will put it as gradient to make you not confused with this m. This is different m. I put it as gradient and this is your x-axis. Okay, that means you need to plot a graph of y square against I square. You have graph paper. You have graph paper. You need to plot it. This is your title here. Graph of y square against I square. You need to find a suitable, what we call a suitable range. You don't want to plot it like. So you need to find a suitable range. What you need to do here first is to retabulate this. Now you need the data of I square and y square. So I square is a square, y square. I want you convert it directly to meter square. Okay, that means something like this. Right? For the first one, I 0.1, you square it up, you will have 0.01. The below one, you have 0.014. Convert it to meter first and then you square. Convert it kepada meter first and then you square. You will have something like this. 1.6 times 10 to the power of negative 8. And the second one, you will have alright 6.766 times 10 to the power of negative 8 and so on so on. So here the rules to draw the graph if is given in your lab manual. Starting from here, plotting the graph. The first one you need to do is choose the of axis and scale. You need to choose the axis of scale. It's what we call its rule is you need to choose manipulated quantity as the x-axis. We have choose I square and dependent quantity as your y-axis. We already choose it as y square and you need to put it cover at least half of the graph paper. So your graph paper is A4 size. It must be bigger than half of the paper, not less than, because if you have a too small graph, it is harder to read the paper. And then of course you need to give a title. I gave you before. One, you need to have a title. Alright, cari title sendiri, find your own title. And then choose choose axis and skip. Alright, we have already choose it as your y-axis is y square, meter square, and your x-axis is sorry, I square, which is its unit is a square. So for y square, most of the value you will be multiplied by times 10 to the power of negative 8, right? So we will use the value this to plot later. Let's say you just put it in here as times 10 to the power of negative 8 meters square. But in calculation, don't forget this. Okay, don't forget this in your calculation. You will be plotting as 1.96 and here 6.78. Okay. For x-axis, did you remember that we can cut off here? We can start it. For example, you are starting from 0.01 and you will have something like a bigger one lah. You can cut it here or you can cut it here. So let's see, for example, you have a data of starting from 8, then it increment as 10, as 12, increment by 2 lah. So you can start here, you put it this seesaw and start with 8, 10, 12. So it will reduce the apa ni jimat space lah. It will save your space. Okay. You can have this seesaw, what we call this, I don't know what we call this. You can have it in x-axis or in y-axis, right? Okay. This is for the one. Ada seesaw tadi kan? Seesaw sini. Alright. Next, dia kata, your lab module said that marking the data point and plotting the curve. What you need to do is plot it as x, plot your value as x. Let's say something like this lah. I put it something like this, plotting as x, and you need an extra point known as centroid point. The calculation is here. Find your centroid point, which is you need to adding up all the data here, semua data kat sini, all the data here, divided by, you have 8 data, 1, 2, 3, 4, 5, 6, 7, 8. So you adding up all the data, divide by 8. Same here, adding up all the data, divide by 8, you will get the centroid point. Show the calculation. Show the calculation in the space provided. Show. And then put it as here, x bar, y bar, to show this is your centroid point. Marking your centroid point in your graph as cross with a circle. Okay, cross with a circle. Okay, now you want to find the curve or the straight line graph. Straight line graph, it doesn't have to passing through all the points, but the line must be passed through the centroid point and balance. Balance, which means it has same number of data point on each side. You need to find a straight line that passing through the centroid point and have balance, what we call balance data. So you will have 4, 4, sebab because your data is 8, so you will have 4, 4, or 5, 3 is acceptable. 3, 5 is also acceptable. Okay. If you look at your equation, there is no y-intercept. Okay, there is no y-intercept. It should start at 0, 0. But since we have this seesaw, we have this seesaw here or here, you will have your line is not at 0, 0. It depends on your graph lah. If you choose a suitable graph without the seesaw, you will have start here. But it is okay if you passing through any line here ke, line here ke, it is okay as long as you choose a straight line. Right? Next, we want to find the question ask you. Let's see. Kalau tengok kat sini, the question ask you to find this. To find this, you need to find the gradient in the graph. Okay, so the gradient, how to determine the gradient. First of all, uh, you need to choose 2 points on the line and make a right angle triangle. This triangle should be greater than 2/3 of the graph. More than 2/3 of the graph. You need to choose a bigger triangle. So let's see. You choose. It doesn't matter if it doesn't touch the point that you choose here. It must touch the line only. You choose here x1, y1, and here x2, y2. Right? x1, y1, x2, y2. Draw the triangle. It is compulsory to draw the triangle and show that it is right angle triangle. This little square showing that it is right angle triangle. Then find the gradient. You need to show the gradient calculation in the graph paper near the triangle. You will have y2 minus y1 equal to x2 minus x1. Here you will get a value, a number lah. You get the value because we want to solve the question number 3. Right, you already get the gradient, and we know the gradient is here. This is the gradient. This is the gradient, and we want to find the E over N. So this is your gradient. You already got the gradient in this graph. What you need to do, just move it this to here. But it is already so much unknown here. X, you have mu naught, you have V, you have pi, you have D. Only pi is available here. That's why you need to read the question properly. All the value is given here. You just need to convert it into SI unit. This is already SI unit. This is need to convert to SI unit, which is to convert to meter. This is kilo, which is 10 to power of 3. This one is need to convert to volt. This one need to convert to meter. Everything is already here. You just substitute into the equation and find the value. This uh, show the calculation. You will have E over N here. Show the calculation in the page provided. Okay, show the calculation here. Given here. So much, so much space here. Okay, now habis. The end of the experiment 1. This is individual. You need to submit it as individual. Scan it. You draw it by your hand, right? You draw all the sketch by your hand. Scan it in the form of PDF. You can have, uh, I'm using Adobe Scan. Adobe Scan. Using Adobe Scan. Scan it in the PDF and submit it in Putra Blast. Don't forget to rename it as your lecture group, your attendance number, your name, and put it as experiment 1. Okay? Alright, I think that's all from me. Thank you.